Hi, ladies and gentlemen. In today's videos, there's going to be three videos. In today's videos, three short videos. In today's videos, we're going to be talking about solving inequalities. Now, over the last couple of days, we've been talking about solving equations. Equations have equal signs. Inequality statements have greater than or less than, less than and greater than, less than and equal to, and greater than and equal to. So we're going to be solving inequalities, basically equations that have these symbols instead of equal signs. And it's the same basic process, but there's a couple of things that we got to remember about the way that inequalities work. So this first video is just going to be a quick reminder on some of the things that you need to remember about inequalities. First off, just real quick, which one's bigger, 4 or 6? What symbol would we use for 4 or 6? 6 is greater, 6 is bigger, so we use a less than sign. We usually start over here and we read from left to right. 4 is less than 6, so we use a less than sign. I can always read it the other way around and say 6 is greater than 4. Both of those are true, but I'm going to use this symbol. But what if I flipped it around? What if I wrote the numbers in another order? Is it the same symbol? What do I need to do? What do I need to write here to make this statement true using inequalities? 6 is greater than 4. Of course, I can always read it backwards. 4 is less than 6. So whichever way I read it, I've used the correct symbol. So inequalities are all about order and making sure that whatever symbol you use, the statement is correct. 4 is less than 6. 6 is greater than 4. We know that to be true. We need to make sure that we use the correct symbol regardless of how we write it. If we flip the numbers around, then we need to make sure that we write the symbol appropriately. Let's look at negative numbers, because negative numbers sometimes can be difficult. What if we had -7 and -2? Well, in order to remember stuff like this, let's look at our handy-dandy number line. In our number line, the greater side is always the side that's going to positive infinity. Oh, that's a terrible infinity symbol. Less than is always the side that's going to negative infinity. So we're down here on the negative side, -7, -2. -7's right here, -2 is right here. -7 is less than, -7 is less than because it's closer to the less than side. -7 is less than -2. Well, what if I flip those numbers around? -2 and -7. What's the relationship now? Well, if we look up here, we realize that if we flip the numbers, then we also have to flip the symbol. We need to use the opposite symbol. Let's just verify that on our number line. So -2 and -7. -2 is greater than, because it's further to the right, -2 is greater than -7. And that makes sense. We see that our symbols became the opposite. So you're just going to remember the rules for inequalities, that the greater than sign, the greater than side is always going to the right. The numbers that are less are always going to the left. And as long as you can remember which one's which, you'll be able to put the correct symbol in its spot. Now, a lot of times when we're solving inequalities or we're solving equations, we'll end up with something that looks like this. We'll say x is 4. And we'll do our math and we'll come out with some number and it'll say x is less than 4. So say that's the answer to the problem. But what if we wanted to flip it around? What if we ended up with something like this? In order for this statement to be true, we need to use the opposite symbol. Sometimes when we're doing our math, it'll just come out where the x is on the right-hand side. Say we had -3 and x. When we did our math, and we'll do some examples here in a second. When we do our math, we'll say that -3 is greater than x. Well, normally when we rewrite this, we write our answer with the x on the left-hand side. Well, in order to make sure that this inequality statement stays true, what do I need to do? I need to take the symbol and I need to use the opposite symbol. I need to flip it over and use the opposite symbol. So whenever you're writing inequalities, the name of the game, rule number 1 is always make sure that your inequality statement is true. When you're rewriting, and I want you to write this down, when rewriting, always make sure your inequality statement remains true. So if you rewrite something, it's awesome to rewrite stuff. Sometimes it makes it easier. We always like our answer with the x on the left-hand side. When we rewrite something, we always need to make sure that the inequality statement stays true. Okay, so that's the first thing. The second thing we got to remember is we got to remember how opposites work. When back in, hopefully it was elementary school, you learned about positive numbers and negative numbers. So we're going to just talk about opposites for a second. Opposites. So if we had 5, right, from 0 to 5, we're going in this direction. But if I make it, if I add a negative sign to this 5, what happens? I got to go in the opposite direction. A positive and a negative are opposites. And what we've got to remember is that whenever we add a negative sign to something, when you add a negative sign, everything becomes opposite. Everything becomes opposite. Now, hopefully you remember this from middle school when you guys did inequalities in 6th, 7th, and 8th grade. Let's do some examples. We're talking about adding negatives and making things opposite. 4 and 6. Let's go back to this 4 and 6 example. Which one's bigger? 6. The inequality statement is 4 is less than 6. Now, if I were to multiply this by 2, if I do it on one side, got to do it on the other side. 4 times 2 is 8. 6 times 2 is 12. All right, well, what's the inequality symbol? What's inequality symbol makes this true? 8 is less than 12. Okay, so if we multiply by a positive number, everything's good. What if we divide? 4 divided by 2, 6 divided by 2. What's 4 divided by 2? What's 4 divided by 2? 2. What's 6 divided by 2? 3. Okay, well, what inequality symbol makes this true? 2 is less than 3. So the inequality symbol stays the same. So if I'm dividing by a positive number or multiplying by a positive number, everything's good. Let's take the same 4 and 6. 4 and 6. What symbol makes this true? Less than. All right. Well, now let's multiply by negative 2. Negative 2, negative and a positive make a negative. 2 times 4 is 8. Positive and a negative make a negative. 6 times 2 is 12. Uh-oh. Everything just went wonky on me. I was dealing with 8 and 12, which are down here on the number line. Now I'm dealing with negative 8 and negative 12, which are down here on the number line. What happened? Everything just became its opposite because I introduced a negative. Negatives makes everything opposite. So now I'm on the opposite side of the number line, and let's remember what's going on here. So I got 8 and 12 would be right here, so negative 12. What symbol is correct? 8 is to the right, is greater than, negative 8 is greater than negative 12. Uh-oh, what happened here? This symbol became its opposite because a negative makes everything opposite, including the symbols. And hopefully we remember that from middle school, that when we're multiplying and dividing by negative numbers, we need to, in order to make sure the inequality statement stays true, we have to use the opposite symbol. Now, usually it's not about multiplication. Usually it's about division. So let's do a division example. 4 and 6, the inequality symbol is less than. If I divide by negative 2, divide by negative 2. If I do it on one side, you got to do it on the other side. 4, positive and negative make a negative. 4 divided by 2 is 2. Positive and negative make a negative. 6 divided by 2 is 3. Okay, well, let's look at our number line again. We've got negative 2 and negative 3. Let me move this up. Negative 2 and negative 3. Negative 2 and negative 3 is right here. Which one is greater? Which one is to the right? Negative 2. Negative 2 is greater. Negative 2 is greater. Uh-oh. Happened again. My symbol became the opposite because I introduced negatives into the problem. A negative makes everything its opposite, so the answers became the opposite and the symbol became its opposite. It's a very important rule to remember. In order for this inequality statement to remain true, when you're dealing with negative numbers, multiplying and dividing by negative numbers, the sign, the symbol, has to become its opposite.